Today is the 15th of March 2024, and this will be our 7th video on trigonometry. Before I start the lesson, okay, as usual, thank you to everyone who have subscribed to our channel. Okay, I appreciate it a lot. If the channel is helping you, okay, please, if you haven't subscribed already, please consider subscribing, sharing, liking, and following us. Okay, I will appreciate it a lot. In my culture, it's when you say please, it's not begging. Okay, it is a way that you know how to be decent. Okay, a decent person will always say please, thank you. Okay, you don't just take things for granted. Okay, so saying please doesn't mean I'm begging, but genuinely I'm appreciative and thankful about the fact that your contribution of subscribing is also good to share the message. Okay, yeah, so let me leave it there for now. And if the account is not yours, again, please, okay, ask permission from the account holder. Don't misuse people's accounts, okay? Or next time when you are going to wherever you are watching it from, whether a friend, take your phone with you. Ask them to help you open your own account, subscribe, and then when we upload, you get your own notification. Okay, and after watching, share, like. Okay, I'll appreciate that. In the comment section, you normally see please follow my notes and script. Okay, at times I realize that it is good. I've always done presentation with notes. I have never gone to a presentation without bullet points or notes. Okay, because I don't want to go off track. Okay, but at times maths has a lot of numbers. So for instance, this is a lot of numbers here. 0.42857143. Okay, so assuming you had 0.4857 or one of the numbers are missing, go by the notes. Okay, because if I'm here, I'll be definitely talking about this, so go by the notes, please. And I know that if you are doing your Gcse, you are very matured and you can understand me. Okay, so please go by the notes. Or even if you are in year 7, you can understand me well. Okay, so go by the notes. Please beware of scammers. Okay, beware of scammers. Take care of yourself online. On that note, again, I'm not begging, I'm just asking you to be safe. Okay, don't assume anybody that send you a friend request is me and you start chatting them up. It's not me. I wouldn't do that. Okay, so please follow my notes. Beware of scammers, please. Okay, recap. we are doing a lot of interesting things on trigonometry. Okay, this is one of my favorite topics. I don't really like talking about favorite topics because in maths everything is my favorite, but this is one of the topics I really like. Okay, so please watch last video for recap. Okay, please. Now, in a short summary, we've looked at how we can use Pythagoras, SOHCAHTOA, okay, and now we've started to look at angle of elevation and depression, okay, and then we are looking at examples. Okay, today's video will not be that long. Okay, so we are looking at some examples. So I'm going to just share examples with you today, a couple, and then I would like you to go away and think about it. Okay, because these are possible exam questions. I remember when we were doing exam question, a similar one came. So please, just go back and look at it, understand it, look at how I solve it, look at my train of thoughts, okay, and try and make it your own. Okay, don't just follow, don't just learn without understanding. Okay, because if you get stuck, then you are stuck. But if you understand it for yourself, then you can always solve it in an exam with nobody's help. Okay, so the challenge I'm giving you is to go away today. If you take a question, understand it. Okay, if you get stuck, go back, watch the video, go back and solve it. I bet you if you do that 2 or 3 times, you should get it. Okay, and if you learn that way, a day before the exam, you shouldn't be awake cramming. You should be having a good sleep. Okay, because by the fact that your mind has relaxed, when you get to the exam room, it doesn't, even if they twist the question a little bit, you'll be able to solve it and get your marks. Okay, now our starter, we looked at recurring and terminating fractions. Okay, now this example I'm showing you is just 3. Okay, 3/7, it will recur, okay, because of the prime factor of 7. Okay, so if you use your calculator, after the 2, it rounds it off, the 8 off here to make it 4/3, but actually what happens is it's 0.428571. Okay, it will go on and on and on and on. Okay, so you have to, so it runs the 8 off here. Okay, but this 428571 will go on and on and on unless you stop at some point and run it off. You run the 8-bit off, or you can do 0.43, but it will recur. Okay, so this is an example. Now 5 over 12, I thought this is interesting because of this prime factor 2. Okay, if it terminates, it should have a prime factor of 2 or 5 or both. Because of this prime factor 2, it's going to terminate. Okay, so you have 0.4166666667. So it terminates because of this prime factor 2 here. Now, the third one, 7 over 90. So 90 can be broken down as 3 and 30. 30 can be broken down as 3 and 10. And then 10 can be broken down as 2 and 5. So you have prime factors of 2, 3, and 5. So that one will also terminate because of the 2 and 5 prime factors. Immediately you see 2 and 5. Okay, on the you look at the denominator and you can break it down to a prime factor of 2 and 5. It doesn't matter any other, it is going to terminate. But assuming you see 3, 7, 11, it is going to recur. Okay, so if again they ask you, will these fractions terminate or recur? Okay, then you can say it will recur because the denominator has a prime factor of this. Okay, or it terminates because the denominator have a prime factor of 2 and 5. Then they might go ahead and ask you convert this decimal into fraction, which you can use the long division method to do. Or if it's a calculator paper, you use your calculator to quickly do it. Okay, but if it's a non-calculator paper, it might be something like 9 over 1,000, okay, or 3 over 100. Those kind of which you can easily do without a calculator. Now this is another one. 11 over 36. 36 is 3 times 12. So 12 can be broken down as 2 and 6. 6 can be broken down as 2 and 3. So here, because you have a prime factor of 2, even though there is a 3, it will terminate, as you can see. So 11 over 36 will be 0.30555556. Okay. Now today we want to look at more angle of depression and elevation examples, and then our next video we'll look at another aspect of trade. Okay, and then use that to also maybe we'll look at the cosine or the sine. Okay, so today I have a question where you need to apply the sine rule first, and then you go on and apply SOHCAHTOA to solve the question. Okay, so far the question we've been seeing are questions that uses mainly SOHCAHTOA to find the angle of depression and elevation. But I said it's good you sketch to get the right function, because if you don't sketch in your mind, you don't sketch and you do it from your mind, and you are supposed to use sine and you use tan, then all your effort is in vain. You understand the principle, but you use the wrong function. And these questions normally they are 4 or 5 marks. Okay, so you don't want to do uh, do that. You don't want to miss those marks. You want to collect them, collect as much marks as possible. So here the example is a stone is 50 meters from the base of a high-rise building. So if you go to some of these towers, some of them have stones on the nearer where people sit. Okay, some of the stones are flat, so you can sit there and guess, maybe relax or read on a good day, or some of them maybe might be um, garden furnitures. Okay, but at times in the summer you see people just leaving their rooms, going to lie on them. Okay, so this high-rise building, which is like a tower, has a stone 50 meters from the base of the high-rise building. The elevated angle to the top of the tower from the stone is 74 degrees. This is where we are. The first part of the calculation question, calculate the height of the building. Give your answer in the nearest whole number. Okay, if they ask you to do that, please do that. Okay, don't read, solve the question, and don't follow this instruction. Okay, please. So now we are going to sketch. So this is my sketch. So this is the stone. You can use like a square box. Okay, now this is the high-rise building where I have just tried to use these bars to like make it how many floors. It could be more, it could be less. Now if you sit on this stone and you lift your eyes up to the top of the building, you make an angle of 74 degrees. Okay, from where you are to the top of this building. Okay, now the stone is 50 meters away from the building. So that looks like a right angle triangle question, a right angle triangle. So here we need to find the right function. So we have the adjacent, and we are supposed to find the opposite. Okay, so we are going to use TOA, which is tan. Okay, so tan of the height will be equal tan 74 will be equal to opposite the height divided by adjacent 50. Remember, it's in meters, so whatever height you get, you should put your answer in meters, but to the nearest whole number. So now, as I've said, we are going to use tan. So tan 74 degrees will be the height of the tower over 50 meters where the stone is away. So the height equals 50 times 74. Again, this will be a non-calculator paper because there's no way you can determine tan 74 without a 4-figure table. So times 74 from the calculator is 3.4874. Then you multiply by 50. So you get a height of 174.37 meters. If you leave your answer like this, yes, you can have 174.3 meters, but they've told you give your answer to the nearest whole number. So the nearest whole number to this is 174 meters. Okay, so this will be your nearest whole number. Let's have a look at another question. Okay, now this is the question, and then the second part of the building. Yeah, what is the angle of depression from the stone from the top of the high-rise building? So here again, if you look at it, okay, if you sit here, you make an angle of 74 degrees. So your angle of the stone, if you stand here, depression, that angle here will also be 74 because of C or alternating angles. Okay, so the second part I've explained to you. So the second part, what is the angle of depression from the top of the building? That was 74 because of alternating angles. So if you write 74, the question might ask to give a reason. So that will be because of alternating angles. Example again, using sine rule. Okay, they won't tell you that, but you have to guess it to solve questions. Okay, consider this diagram. Okay, so this is the question I was talking about. We will apply sine rule first, find this side or that side, and then use that with one of the angles to find this height here. Okay, now where A, B, C are points on the horizontal ground. Okay, so you have a flat surface and then A, B, C on the ground. BT is a vertical tower, like we just saw. Okay, the angle of depression from T, you remember bearing. So angle of depression from T here is 21 degrees. So if you are here, your angle of depression here is 21 degrees. You remember bearing. Okay, so there 21 degrees. Your angle of the angle of elevation from T. Okay, so you have T. Okay, then you move clockwise, so it's 21.5 degrees. Angle of elevation of T from C here is 13.3 degrees. That one, that is 13.3 degrees. Again, not to scale. So this is the diagram we have. We have two angles of elevation. So if you stand here and you look up, okay, this is your angle here, there 21 degrees to the tower top. If you are at the point C and you look up, this is 13.3. Now A, B, and C is 1,200 meters. Okay. Now, you need to find the tower, this height here. Okay. First of all, we know that the total angle in a triangle adds up to 180. So if this is 21.5 and that is 13.3, then this will be 145.2, that one here. Okay, you were not given this. Okay, so we find that. So now we are going to use our sine rule. So the sine of this angle will be equal to the length opposite, or the sine of this angle will be equal to this length opposite, which we don't know, 80, or the sine of this angle will be equal to the length opposite, which is TC or CT. Okay. So first of all, we use the sine rule. We use the sine rule to find AT or TC. Okay, so let's look at what we did there. So applying the sine rule, I didn't write it out, but I'll just explain it to you. So 1,200 over sine of 145.2 will be equal to TC divided by sine 21. Okay, so the length and the angle opposite. Okay, and I've explained why this is 145, because it's a triangle. So if you take 21.5 and 13.3 from 180, you get 145.2, which is opposite of 1,002. Okay, and the angle 21.5 is opposite TC. In the same vein, 1,200 over sine 45, sine 145.2 will be equal to 80 over sine 13.3. So you can either use this or this. In an exam, you can just do one. You don't need to do both. Okay, it's a learning platform, so I'm trying to show you whichever one you use, because you have your calculator anyway, but in the end you should arrive at the same answer. So I'm going to use this, the first one. So TC now will be equal to, using sine rule, 1,200 over sine 145.2 times sine 21.5. Okay, so TC will be equal to 1,200 sine 145.2. On the calculator, it will give you 0.5707. Sine 21.5 will give you 0.3665. So you do 1,200 divided by 0.5707, and then you times by 0.3665. If you do that correctly on your calculator, you should end up getting 770.6. Okay, TC. So now that you know TC, okay, I'll show you. Okay, now that you know TC, you are ready to find the height. So we've just found this side. Okay, and because it's on a horizontal ground, That is a right angle triangle, and that is also a right angle triangle. So we know this side. We want to find this height. We know this angle. Okay. So we've just found this side. So the sine of 13.3 will be opposite over hypotenuse. Again, you can sketch it to help you. Okay, because if you don't, this one, the diagram was given to you. Assuming it wasn't given to you, you can sketch it on your paper to help you answer. So we are now going to use sine. So we've already found this TC here. This is where we are now. Okay, so now sine of 13.3 will be equal to opposite, which is the height of the tower, over TC, which we just found, which is 770.60. So BT, which is the height of the tower, will be equal to 770.6 sine 13.3. Okay. Sine 13.3 on the calculator is 0.2300. Okay. Now, if you multiply correctly on the calculator, you should get 177.3 meters. This is to one decimal place. In this question, they haven't asked us to leave it the nearest whole number or whatever. They've just allowed us the room to decide. So I've left it to one decimal place. Okay. So this is how you can look at questions. Okay, I think we solve it. So this question that we've just done, it's trick, but you have to use the sine rule first to find the hypotenuse, and then you use the right function to find the height of the tower. Okay, and that will be the height of the tower then. Okay, again, these are cool marks. You can't go wrong if you study this properly. Okay, now if you've not subscribed already, can you please consider subscribing? Okay, and like, share, follow. If you share and they don't like, you've done your bit. Okay, share the video, because it will help somebody. One person complaining doesn't mean we cannot come and do the video. We won't be, I normally will be happy that everybody who is doing, they have 100% A start to C grade. Okay, so that people can just get on with their lives. Okay, now subscribe, share, follow. Okay, and follow my notes. Okay, today there's been a lot of numbers, so just follow the notes. Okay, and take care of yourself online. Don't be scammed. Okay, please. We are not taking money or donations. It's a learning platform. We want as many people who need the extra help to get it. Okay, so do not be scammed. Okay, thank you for watching today's video, and I'll see you in the next.